So welcome to our C programming lab in our RTU programming languages course, and today we will learn how to set up your computing environment, especially for C language, and we will use GitHub Codespaces, which is a virtual computing environment, basically a virtual server somewhere on GitHub servers owned by Microsoft, provided free for us, students and teachers, and we will be setting up, it comes with Visual Studio Code, your integrated development environment, and also comes with a compiler, GCC. And underneath you have Ubuntu running. But okay, so how do we do this? There are actually only two simple steps to get started. So first of all, you need to be logged into your GitHub account, right, github.com. So if you don't have a GitHub account, you should create one. So that's the first step. So assuming you already have created an account, what do you do next? You go to this site. This is my repository, owned by me, public. So you can freely clone or fork. So what we want to do is fork it. So what you do is you click on fork, and this will fork, meaning create your own copy, right? You can make it private or public. I recommend public. It will make things easier at the beginning, meaning of course your friends can see what you are doing. That's the only downside. If you want to be completely private, you can make it private and then only assign rights to me. That's slightly more complicated. But let's see, let's stick with public for now. And then it takes maybe 20 seconds, maybe 30 seconds, since it's a small repository. And once you have, instead of having my name here, right, you'll go to yours. So it'll be your username and the same name probably, right? And what you do then, once you are at your own copy or fork of this repository, you click simply on Codespaces. I actually have some created already, but I'll make a new one for this video. Create a Codespace on main, right? So what will this do is create this virtual machine somewhere on GitHub servers. Most likely Europe, maybe in America, right? I think it's in Europe. Microsoft has servers everywhere. So, and it's running Ubuntu, right? You get, as default, you get about, I think, 2 CPU cores, virtual cores, right? You share resources with others, but this is your private one. And I think 4 gigabytes of memory. And this is, you might say, how much resource? I mean, is everything free? I mean, we're students and teachers, you know, we like free stuff, right? So I think you get 120 hours for free. You know, anybody gets 124 hours for free, 120 hours. But if you're a student, you can apply for educational account. I'll probably make a video later on if you don't have one already, and you get more resources. But even these 120 hours, that translates to, I think, 60 hours of this particular resource. And I think 60 hours should be enough to do it every month, right? 60 hours, that's plenty of time. So, I was talking, it takes about 1, 2, 3 minutes, depending how busy the server is, and we are good to go. We have a running server, we have our environment, and we can use this this address, right, to branch from anywhere in the world, right? You don't need a fancy computer, right? You can be running this from a potato, basically anything that, well, Chrome, or you know, you need a good current browser. That's the only downside, right? It's suggesting to configure C++ IntelliSense right now. It will be asking this a couple times, some C++ questions. I suggest for now we'll ignore it. I'll say no, right? You can, if you want, C++, because remember, we are not doing C++. There's a big difference between C and C++, even though C++ was heavily inspired by C. It's basically used to be a superset of C, but it's not anymore. Right, there's some significant difference actually. So, but we have a C project, so which basically includes all the files were transferred from here into this virtual server. And for those who have used Visual Studio Code, it looks like Visual Studio Code because it is Visual Studio Code, except it runs on so-called cloud, which is basically somebody else's computer. Right, so let's take a look. How do we explore what we have here? So main thing that you really care about is, where you're doing work, is source folder, which is typical for storing source files, right, typical organization. So we have these 3 files: calculator, format specifiers, and hello C, right? We also happen to have already pre-compiled these files already, meaning they are already compiled and ready to run as executables on this machine, on this virtual machine. So hello. So how do you run this program? If you only have a binary file, right? That's end product. You don't need any code. We just want to run it. So how do you run it? Well, it lives in a binary folder, right? So we go to binary folder and we press hello, right? Type hello, right? And we press enter. And you get hello RTU world from C lab. You passed 0 arguments. Let me pass one argument. So Valdis, right? And I have one argument. And you see that argument I passed. Great. Now you say, okay, but I want to learn some programming. So well, we go to hello C and let's do some adjustments. For example, I see already, I'm going to skip this again. I see already some formatting issues. For example, there's double escaping. I'll do this new line here, right? So some adjustments, maybe like the comment. Yeah, this is just a friendly comment, right? This is your first C program, my friend, right? So maybe not your first program, maybe not, right? So, and also hello RT world from C lab, right? And I could add something else in 2025, for example, right? So some simple adjustments. Again, since you guys have written code in code, you see what happens if I don't pay attention, right? Comments, right? Since you did Java before, it should look pretty familiar. The syntax, I mean, not for nothing, Java takes a syntax from C, right? So C is sort of basically the granddaddy of, grandmother of all the C-based languages, whole bunch, the syntax-wise, right? Not semantics-wise. Semantics might differ a lot, right? Between PHP and JavaScript and Scala and Rust and, you name it, right? But this is the granddaddy of them all. Of course, this has been like 50 plus years. There have been some changes, but overall things have stayed pretty constant, right? So, well, some things have changed here, but we made the changes here in the code, and what do we need to do? We need to compile it. Well, we could do it manually by typing GCC and some commands. Luckily for you guys, we're using standard way of development. We have makefiles, which includes the standard flags, it's sort of like a extra language for how to build things, right? Not only C specific, works for other languages. And basically we do something like this. We do make, I could do make all, but since I didn't make changes to formats and calculator, I'll do make hello. So make hello, and you can see what happened here. You see that's command was passed. These are extra flags which show extra error reporting, very pedantic, meaning very strict, because you're learning, so it's going to be strict. And it also shows you where the output goes. It goes to bin hello, right? So you could do this type of command by hand and maybe adjust if you want to make another copy, make it maybe, I don't know, somewhere else. I mean, you can play around with it, but make files are really, really useful because you don't want to keep, typing a long chain of instructions. Because remember, programmers are lazy. And it's, good programmers are even lazier than the regular programmers. Okay, now, and again, you can run this, if you want to run hello, make run hello. It's kind of silly, but you can see, right, we don't need this. So that's exactly what we did before, right? .bin hello, right? You passed 0 arguments. So we could do this, change directory, cd bin, right? And we could do, hello directly, right? Hello, right? Or I could do hello Valdis RTU, right? And it also works. Okay. Now, so hopefully everybody is up to speed now. Everybody has compiled, has already made some changes to their programs, and that's the goal today. Make some changes. And now, what happens at the end of the day? Meaning end of this lab, how do you save your work, right? Well, you notice here, right, there's a repository and it says the changes. So you write a nice commit message, adjusted formatting in my case, right, adjusted formatting, right, for hello world, right, and commit. And this will say, okay, there are no stage commit, that's fine, automatically I'll do this for this again, and sync changes. And this will do, it will sync the code here, right, with the repository, meaning your copy, not mine, right. So periodically gonna git fetch, sure, why not, right? And to update the changes from if somebody makes changes in your repository, I don't know, your friend maybe, but no. So let's go back here. So now the changes should be reflected here. Let's double check. And now, right, you see the changes were pushed back to the GitHub repository. All right, so your goal today is to get something running, maybe make some changes, and submit the link with your username, right, to the link in Ortus. All right, so thank you everyone, and good luck and happy hacking.